In this video, we're going to go over a common physics exam question involving two trains that weigh different masses, moving at different velocities when they meet head-on. The ultimate goal of this problem is to determine the mutual speed after the collision. So let's go ahead and read the problem. Train A weighs 110 kilograms, moving at a speed of 2.5 meters per second, and it meets head-on and holds on to train B, which weighs 90 kilograms, moving at a speed of 5 meters per second. What will their mutual speed be immediately after the collision? Express your answer to two significant figures and include the appropriate units. So to start this problem, we're going to go ahead and draw a diagram. So train A has a mass of 110 kilograms. And that will be our M1 value, and is moving at a speed of 2.5 meters per second. And it collides with train B that weighs 90 kilograms, which will be our M2 value, moving at a velocity of 5 meters per second. So the collision, when they meet head on, we'll know that A is moving in this direction and B is moving in this direction. Once they collide, then they will have a new velocity due to their weight and the conservation of linear momentum. So we're trying to solve for V, which is the common velocity. To solve this problem, we're going to need the conservation of linear momentum equation, which is as follows. M1 times velocity 1, initial velocity of the first object, so train A, plus M2 times the initial velocity of 2, in this case that would be B, is equal to the velocity, the common velocity, times M1 plus M2. So to solve for V, we have to move this equation around a little bit. And after you move the equation around, V will equal M1 times U1 plus M2 times U2 over M1 plus M2. This is the equation I'm going to use to find the common velocity. So we'll go ahead and plug our numbers in. V will equal M1, which is 110 kilograms, times U1, which is the initial velocity of train A, 2.5 meters per second, plus the mass of 2, which is 90 kilograms, times negative 5 meters per second over 200 kilograms. The 200 kilograms is just the masses added up. And the reason that the velocity right here is negative 5, because train B is moving in the negative x direction. Therefore, its velocity, its initial velocity, will be negative. After calculating this, we'll find that V equals 275 minus 450 over 200. Solving it further, we will find that the common velocity is negative 0.875 meters per second. Now, some of you may be wondering what the negative sign is doing after all this. So the negative sign just means that after they collide, the common velocity, or the movement of both trains, will be moving in the negative x direction. Therefore, after train A and tray beam collide, they will stick together and move in this direction. That's all I have for this video. If this was helpful, please go ahead and like and subscribe, and I will be posting more videos every week. Thank you for watching, and peace.